Hi students, this is Mr. Yao. In this lesson, we are going to learn how to add and subtract functions, which also involves plugging in eventually to evaluate the functions. So first, let's actually review how we have been combining expressions. Prior knowledge. 2x and 3x, well, they both have the x, so they're like terms, and we just need to add the number in the front, so we got 5x. B, the x's are going to be combined together. 4x minus 2x is a 2x. 3 and the minus 1 is going to be combined together into a plus 2. C, the 3x and the negative 4x can be combined to be a negative x. The y can't be combined with the x, so it's going to stay by itself. So there you go. That's what you have learned before about combining like terms. You should be very familiar with function notation at this point. We're now going to learn how to perform operations with functions. When you encounter questions about operations with functions, you'll generally be asked to do two things. One, combine the expressions in some described fashion. It could be adding, subtracting, multiplying, or something called composition of functions that we'll learn towards the end of the unit. And substitute some value to replace the variable in the original function, which is also called plug-in. And you have done that 2 units ago. The ultimate goal of performing operations with functions is to be able to evaluate them so that we can actually have a number answer. And that's plugging in. The two main approaches, you can either plug the given value into each function separately and then perform the operation, which again is addition or subtraction or multiplication, or something we call composition. The second one is you can perform the operation with a function to actually get a combined function and then plug in the given value into the final answer of the function. Today, you're going to focus on adding and subtracting. Here's the notation. Typically, you have two functions. Yes, you can put the plus minus in between, f of x plus or minus g of x, but we often write it as f plus or minus g of x. Since they are both using the same variable x, that's why we can actually write it this way. And this means the addition and subtraction of two functions. We simply connect the two functions with a given operation and then combine like terms. Like terms have to have the same variable or basis and exponent. So this is going to be very, very important. Anytime you work with like terms, the requirements or definition are exactly the same. Same variable or basis and same exponents. The final answer should be in standard form, which means the exponents of the term should be in descending order and a number in the end. The important thing, make sure to put each function in parentheses before any operation, especially when you're subtracting a function. Now let's have a look at some examples. Example 1. First one, f plus g of x. So this is the same as f of x plus g of x. We're just adding them together. So f plus g of x, that is just going to be the first function, 2x squared minus 4, plus the second function, x squared plus 4x minus 2. We're putting them inside parentheses. The connection operation is addition, which means we don't have to change anything, so we can open them. 2x squared minus 4 plus x squared plus 4x minus 2. X squares have to go together. They're not exactly the same as x because the requirement is they have to have the same variable and the same exponents. So that's a 2x squared. The x squared itself is the same as a 1x squared, so together that is 3x squared. We only have one term with an x, so it's plus 4x. Lastly, the negative 4 and the negative 2 together is a negative 6. There you go. Next, g minus f of x. That means we need to put g in the front, which is x squared plus 4x minus 2. And then we need to subtract the f. Remember to put the functions inside parentheses, especially when you're subtracting, so that in the next step, we can actually change the signs. So the first parentheses stay the same when we open them. The second parenthesis, however, since it's subtracting, is like a negative 1 there being distributed with a 2x squared and a negative 4. That's going to become a minus 2x squared and plus 4. Now it's time to combine like terms. We have a 1x squared minus 2x squared. That's going to be a negative x squared plus 4x still by itself. Then minus 2 and a plus 4 is going to be a plus 2. There you go. Then find f plus g of negative 4. So you have two options when you're trying to find this, for example. Since you already found what is f plus g of x, you can actually just plug -4 in there. So f plus g of -4. So again, the first method is you can just do this, actually find out what is f plus g of x, and then plug in a number eventually. So now I can plug in -4. 3 stays there. Remember to put parentheses when you're plugging numbers in. And plus 4 times -4 minus 6. That's a 16 times 3 is a 48. So it's 48 minus 16 minus 6, which is going to give you a 26. So that's one way to do it. Another way is you can choose to deal with that f of -4. So this is the same as f of -4 plus g of -4, which means instead of actually finding what is what is f plus g of x, I can just plug in -4 for both of the functions. So f of -4 is in fact 2 times -4 squared minus 4. That is going to be a 32 minus 4, which is a 28. And then I also have the g of -4. That's going to be a -4 squared minus 4 times -4. So we have plus 4 times -4, and then a minus 2. So we have a 16 here, subtracting a 16 minus a 2, so it's a -2. And then eventually, I can just add them together, which means 28 plus a -2 is still going to give us a 26. So it's the same answer. So if a question is just asking you for f plus g of -4, you don't have to add them together. You can just plug in separately, and then eventually perform the operation. Since it's plus, so we're adding the two numbers together. That's the other way to do it. Now for the other one, g minus f of -2, you already found what is g minus f of x, so I can just use that. -2, that's going to give us a negative sign, and then -2 squared plus 4 times -2 and plus 2. That is going to be a -4 minus 8 plus 2, which is a -10. There you go. That's example 1. You can pause here and try example 2 and example 3. Now let's have a look at example 2. First, f minus g of x means I need to use the first function, a cubed plus 5a squared. Subtracting the second function, let's put it inside parentheses. Okay, so that the next step, we can actually get rid of the parentheses, but make sure to distribute the negative sign. A cubed plus 5a squared minus 2a cubed minus 4. Okay, a cubed minus 2a cubed is a -a cubed. And then the second term is a plus 5a squared, eventually a minus 4. And I just remembered in example 1, we do need to make sure you're putting everything into standard form. And again, standard form means all the exponents have to be in descending order. So you see a square in the front, and then this is like a first power and the number on the end. Same thing here, square in the front is like first power and then the number in the end. So it has to be in that order, which is called a standard form. Okay, let's continue with example 2. Okay, next we have g plus f of x. So that means we're putting the second function, adding the first function. When we get rid of the parentheses, well, nothing is going to change, so we can directly add them together. 2a cubed and a cubed is 3a cubed. The next thing we're going to look for the squares, which is a 5a squared. So when you look for things in a certain order, in this order, you can already make sure your final answer is in standard form. And then the number on the end. Next, it's time to plug numbers in. F minus g of -5. Since I already found it, I can just plug -5 in there. So it's a -5 cubed plus 5 times -5 squared minus 4. That's going to be a positive 125. So this is a negative 125 with a negative sign in the front is a positive. And then the next one is just going to be another 125, eventually minus a 4. So it's 250 minus 4, which is 246. For the other one, g plus f of 2. So now I can plug into the answer I already got. 3 times 2 cubed plus 5 times 2 squared plus 4. So that's 3 times 8, which is 24. 5 times 4 is a 20, and a 4 on the end together. That is 48. Again, if you haven't found all of these, you can choose to just find f of negative 5. So this is the same as f of negative 5 subtracting g of negative 5. So you can plug negative 5 into the first one and plug negative 5 into the second one. Whatever answers you got, subtract them. That is example 2. Moving on, example 3. So f plus g of x, first function, negative 3x squared plus 3x minus 2, plus x squared minus 2x plus 5. Since it's addition in the middle, when I get rid of the parentheses, nothing's going to change, so I can already combine them together. Negative 3x squared and x squared is a negative 2x squared. 3x minus 2x is a positive x. Minus 2 plus 5 is a plus 3. There you go. Next, f minus g of x. First function subtracting the second function. Negative 3x squared plus 3x minus 2 inside parentheses. Subtracting second function also need to be inside parentheses. So now when I open the parentheses, I actually need to flip all the signs in the second function in the second parentheses. There's negative 3x squared plus x minus 2 minus x squared plus 2x minus 5. Make sure you change all the signs. It's like a negative 1 distributed into everything. So we have a negative 3x squared and another negative x squared. Combined is a negative 4x squared. Plus 3x plus 2x together is a plus 5x. Eventually, negative 2 and a negative 5 is going to be a negative 7. Now it's time to plug numbers in. So f plus g of negative 3 is the same as f of negative 3 plus g of negative 3. Since the previous two examples I showed mostly to just plug in whatever we already found, this time we're going to ignore that. Let's pretend we didn't actually find f plus g of x. Then we can actually find them, we can calculate them separately. f of negative 3 is going to be negative 3 into the first function. So it's negative 3 times negative 3 squared plus a 3 times negative 3 to minus 2. That is going to be a negative 27 minus 9 minus 2. So it's a negative 38. Then we also find g of negative 3. So that means plug negative 3 into the second function. So it's negative 3 squared minus 2 times negative 3 plus 5. So we got a 9 plus 6 plus 5, which is a 20. And eventually, to find this, now we can just add the two numbers together. It's going to be a negative 38 plus a 20, which is a negative 18. There you go. So that's also a way to do it. Now, f minus g of negative 7. So this time, since we already found it, let's just plug it in. It's negative 4 times negative 7 squared plus 5 times negative 7 minus 7. So the first part, negative 7 squared is a 49 times negative 4. So I do actually want to emphasize again, you need to make sure you deal with the square first before you multiply with the number in the front. So same thing here, you gotta calculate negative 7 squared before you multiply with a negative 4 because exponents come before multiplication. So that's 49 times negative 4, which is negative 196, then minus a 35 minus a 7. So it's negative 196 minus 42, which is negative 238. There you go. That's example 3. Moving on, example 4. Now we're working with something else. We're working with exponential functions. But it kind of works very similarly. You have to make sure you understand how like terms work with exponential function. Again, like terms, same base, and exponents. Okay, so for example, if I have 3 times 2 to the x power and 2 to the x power, which is basically like 1 times 2 to the x power. They're like terms because they're both 2 to the x power. The number in the front is just like your 2x squared, your coefficient in the front. However, so they are like terms. However, let's say we have a 3 times 2 to the x power, and the other one is a 1, it's a 3 to the x power. Even though they're both to the x power, that's a base 2, this is a base 3, they're not like terms. Or let's say the first one is a 3 times 2 to the 2x power, and the other one is just a 2 to the x power. Well, they have the same base, but the exponents are different, so they're also not like terms. So that's something you got to be clear about. It has both of the requirements, same base and same exponents. Now let's deal with the question. F plus g of x. So the first one, we have 2 to the x power minus 7 plus 2 to the x power plus 4. So this time, you got to remember, the exponential function we have dealt with typically looks like a times b to the x power. B is the base, x is the exponent. So we do have this a in the front. It's almost like your 2x, your 5x squared, this number in the front. So we do actually need that. And in this case, even though we don't see a number in the front, it's actually a 1 times 2 to the x power, and another 1 times 2 to the x power. So we get rid of the parentheses. 2 to the x power is the function there, so we're going to need to keep that. In the front, we have a 1 plus a 1, so that becomes a 2 times 2 to the x power. And at the end, negative 7 plus 4 is a negative 3. Okay, next, g minus f of x. We're going to have 2 to the x power plus 4 minus 2 to the x power minus 7. Let's get rid of the parentheses. 2 to the x power plus 4 minus 2 to the x power plus 7. Same thing here. This means the 1 times 2 to the x power minus a 1 times 2 to the x power. So even though that's the main function, we actually have a 1 minus 1, which is a 0. That cancels it out. So eventually, we just have an 11. There you go. So now let's actually plug in numbers. F plus g of 2. So we're going to plug into the first function. It's 2 times 2. So we're replacing the x. It's still the same idea as the first 3 examples. When you're plugging in, you're just replacing the x. It's 2 to the second power, then minus 3. So the first part is an 8. So you got to calculate the 2 squared first. That's a 4 to multiply with a 2, which is an 8. Minus 3, that's a 5. G minus f of negative 3. Well, that one, you actually don't have any x you need to plug in. G minus x minus f of x eventually is just 11. So that means no matter what number you give here, it is just going to be 11. There's no x for you to actually replace with. So there you go. That's example 4. Moving on. Example 5. So let's have a look. F plus g of x. That is my first function is 4 times 3 to the x power. So I do actually have the habit of writing this extra multiplication sign to tell myself that this number in the front, the 4, is actually the number I'm trying to add or subtracting. The 3 to the x power is just my exponential function, is my base and exponent. Okay, so let's continue. Minus 6, then plus 2 times 3 to the x power plus 8. So when I open the parentheses, nothing is going to change. So I can start looking for like terms already. This one has a 3 to the x power. This is also a 3 to the x power. Number in the front is a 4 and a 2. So I'm adding them together, which becomes 6 times 3 to the x power. And then the number part is a negative 6 plus an 8, which is a plus 2. There you go. Next, f minus g of x. So f is 4 times 3 to the x power minus 6, subtracting 2 times 3 to the x power plus 8. When we open the parentheses, we're going to subtract. So it's 4 times 3 to the x power minus 6, then minus 2 times 3 to the x power minus 8, because you're distributing the negative sign to the first part and the second part. One thing I do want to emphasize, this 2 times 3 to the x power, they're all together. It's not just going to be like a -2 and then subtracting a 3 to the x power. It won't happen. This is one term together. It's just like your, say, 2x cubed. When you have a negative sign, it won't suddenly become a -2 times a negative x cubed or subtracting x cubed. It won't. Okay, so now this part is a 3 to the x power. That's also a 3 to the x power. So in the front is a 4 minus a 2, which leaves us a 2 times 3 to the x power. -6 minus 8 is a -14. Now it's time to plug numbers in. F plus g of -2. That means I'm replacing all the x with -2. So 6 times 3 to the -2 power plus 2. So 3 to the -2 power is 1/9 times the 6 is a 2/3 plus 2, which is going to be 8/3. Second one, f minus g of 3. So all of these things, again, you can always put in your calculator and then change your answer into a fraction. Okay, so let's see. 2 times 3 to the 3rd power and minus 14. Make sure you calculate the exponent part first, then multiply with a 2. 3 cubed is a 27, times 2 is a 54, minus 14, it's a 40. That's example 5. Last one, moving on. Example 6. F plus g of x. My f of x is 4 to the x power minus 2 plus 5 to the x power plus 9. Okay, when you open the parentheses, you can start looking for like terms. Even though these two, they both have x as the exponent, the bases are actually different. The first one has a base of 4. The second one has a base of 5, which means you can't actually combine them. They are not like terms. You have to just copy them down. 4 to the x power plus 5 to the x power. Then is a minus 2 plus a 9, which is a plus 7. But since we want standard form, let's still put the 5, the bigger number, in the front. So it's 5 to the x power plus 4 to the x power plus 7. Okay, next, g minus f of x. So g is in the front this time. 5 to the x power plus 9. That is subtracting 4 to the x power minus 2. So let's open the parentheses. We have 5 to the x power plus 9 in the front. And when you're subtracting, it's subtracting a 4 to the x power. And the negative sign times the -2 is a plus 2. Same thing. These two are not like terms, so you can't actually combine them. These two are not like terms, you can't combine them. So we're going to copy them down. 5 to the x power minus 4 to the x power plus 9 plus 2, it's a plus 11. Now it's time to plug numbers in. F plus g of 2. We already have everything right here, so let's replace all the x with a 2. This is going to be 5 squared. One thing, you can choose to keep all the parentheses, which is always the safer choice. Okay, so it's going to be 5 squared plus 4 squared plus 7. So it's 25 plus 17 plus 16 plus 7. So it's going to be a 48. G minus f of -1. That's going to be a 5 to the -1 power minus 4 to the -1 power plus 11. We're going to have a 1/5 minus a 1/4 plus 11. If you put in your calculator, that's going to give you, so this part is actually a -1 over 20. So eventually it's going to be a 219 over 20. So that's example 6, and that's everything for this lesson. Thank you.